Okay, for the purposes of the ratio test, the entire thing after the summation symbol is your a sub n. Okay, so now we're going to go off and verify the two requirements of the ratio test. First of all, is this a series of non-zero terms? The answer is yes, right? N could be 0, but because we're starting with 1 and going off to infinity, it's not in this series. And then 2 to the n exponential function, never equal to 0. So indeed, a sub n's are never 0. Number 2, now we're going to find the limit of the ratio of successive terms in absolute values. Sometimes you don't need the absolute values, right? Here, n is positive for all the terms in the series. So is 2 to the n. It's always positive exponential. So actually, we don't need the absolute values here. Make our lives just a little easier. We can drop those. And then now we're looking at the limit of the ratio of terms. So I'm going to start with noting that this is a sub n plus 1 divided by a sub n. So over here, I'm going to write out a sub n plus 1 in a minute, but I'm just going to divide it by a sub n, which I know, right? So I can just plop this in here. Great. To find a sub n plus 1, everywhere I see an n, I put in n plus 1. There's an n right there. There we go. And then there's an n right there, so n plus 1. So now I've created my ratio, a sub n divided by a sub n plus, a sub n plus 1 divided by a sub n. Great. Now I want to do a lot of algebra, right, before we take this limit. So what's the algebra to be done? Well, division is multiplication by the reciprocal. So I just swap where those are in the fraction. And then now I'm going to work on this part. I notice that n plus 1 over n, I can put that together. And then I'm going to put these together. This is 2 to the n over 2 to the n plus 1. And notice that I have powers of 2 in the numerator denominator. 2 to the n plus 1, rules of exponents, is 2 to the n times 2 to the first. And I have a 2 to the n in the numerator, so that's also in the numerator over here. And from here we see that these two cancel. And I'm left with 1/2. So I can replace this term here with 1/2. So I have limit as n goes to infinity, n plus 1 over n times 1/2. And I can pull the 1/2 in the denominator here to n. And now I'm taking n going to infinity for this rational function. Variety of ways you could do this. You could try L'Hopital's rule. You could use that factoid about limit of rational functions as n goes to infinity, or my favorite, the growth argument, right? So as n goes to infinity, the 1 is like inconsequential, right? This is like a trillion plus 1 is basically a trillion. So down here, I'm left with basically n over 2n, which is 1/2. So actually, this limit is 1/2. And now that I've found the limit, right, back to the ratio test, I need to compare it. This limit happens to be, I need to compare it to 1, right? This limit happens to be less than 1. So the ratio test tells me, hey, this series converges absolutely, right? So that's my conclusion here. So converges absolutely.